So here we're dividing rational expressions, and the when we talk about the degree of the polynomials, we talk about the sum of the total powers on all the variables, or the highest powers on all the variable terms. So here, when we simplify this, we're in grade 10 and 11, we start focusing on this problem of dividing by 0. So here, we cannot let x and y equal 0, so we need to state some restrictions. So we're going to say that x is not equal to 0, and y is not equal to 0. And this is the issue of dividing by 0. We don't want to divide by 0. Once we've done that, when we just divide a polynomial, we need to distribute the divide across that addition or subtraction, just like we would with multiplication. So we need to divide these terms. So 3 divided by 3 is going to be 1. x4 divided by x is going to be x cubed. And then y squared cancels out. Plus, then we distribute this division over here. So we're going to divide numbers with numbers, x's with x's. So here we're going to end up with 9 divided by 3 is 3. X squared divided by x gives us 1x. Y7 divided by y squared gives me y to the power 5. Okay, so when we divide these polynomials, you have to remember that this divisor needs to be applied to all the terms in that polynomial. So we'll do the same thing here. We want to first of all state our restricted values. So we'll say that a is not equal to 0. B is not equal to 0. And again, the reason why we state that is because we don't want to divide by 0, because there's a problem with dividing by 0. This divisor gets distributed to both terms. So we divide that expression. 12 divided by 4 is 3. A5 divided by a squared is a cubed. B7 divided by b cubed is going to be b to the power 4. Then we move on to the next term, and we divide these terms. So 20 divided by 4 gives us a 5. A squared and a squareds cancel out. B6 divided by b cubed leaves me with b cubed. Okay, so that's going to be the expression left over. And the degree of the polynomial here, so this was a degree 9 divided by degree 3, so we end up with a degree 6. Okay, or when we divide, we end up with a degree 6. Here we have degree 12 and degree 8 divided by degree 5. We're left with a degree 7 here. So this polynomial that we're left with is degree 7. In fact, we can do that to start with. Well, this one here we can't actually, now that I think about it, because we have the x in it. So this one we can't actually state the degree because there's a variable in the power. So we're going to have to leave that one alone. Still, we still need to worry about dividing by 0. So we can't let a equal to 0 or b is equal to 0. Once we've stated that, then we can start distributing that division. So we end up with a cubed, b to the power 2x divided by b to the power 2. Although we don't know what x is, we know we have twice as many here. So we have half of those cancel out. We're just going to be left with 1x. Divide that. We end up with a squared bx over a squared bx is going to be equal to 1. And everything cancels out. All the times here cancel the divide here. And when we cancel the times and divide, we're always left with 1. Okay, if we cancel add and subtract, we're left with 0. But when we cancel times and divide, we're always left with 1. So this term here, we're going to be left with minus 3a cubed over a squared gives me a. B to the power 2x and b to the x. We're going to take away half of those x's, and we're left with 1x. Okay, so there's a simplified version of those. Okay, so is this statement true? We distribute multiplication across plus minus. We must also distribute division across plus minus? And the answer to that is absolutely yes. Okay, we are definitely going to distribute. Okay, so that's going to be yes with a couple exclamation marks. Any rule for multiplication, division follows those same rules. Okay, so division rules follow multiplication rules and vice versa.